Hello guys, welcome to Kirchoff's laws. Now let's start with the first one. The first law, which is also known as the current law or junction rule. Now, I'm going to make a figure. Now, let's discuss why this is called junction rule. Here, the point A is called a junction because it joins four or more roads in which one current can separate from the two. Let's take this circuit. Now, these points are not junctions because if a current is coming, the only path is to go here. It cannot separate onto other parts. But these points are junctions because if a current is coming from here, it can either go here or here. So these two points are junctions when something can separate from those points to two other parts. Now, let's move on to what the first law says. It says that at any junction in an electrical circuit, the algebraic sum of current is always zero. So what this means is at a junction there will be no current. That is, the sum of current will be zero at a junction. So here the junction is O. So a very simple thing to do here is look at which currents are coming to the junction, which currents are going out of the junction. So we can see that I1 and I2 are coming into the junction and I3 and I4 are going out. Well, if at junction O the sum of current is 0, then that means the current coming into the junction is the current going out of the junction. So I1 plus I2 must be equals to I3 plus I4. Now, this law is based on the principle of conservation of charge because, well, we're dealing with current here, and here at junction O the charge is conserved, and simply current equals to charge by time. Now for the second law, it is also known as the voltage law or loop rule. So I'm going to make a figure. We have this figure. So let's see what the second law says. It says that in any closed path of an electrical circuit, the algebraic sum of EMF is equals to the algebraic sum of potential different. Now why is it called a loop rule? Well, this may seem very complicated, but let's break down into different parts. First we have one big path here, A, C, D, F, and we have two smaller ones, A, B, E, F and B, C, D, E. Now let's take one loop. Let's say the big one, the loop A, C, D, F, A, to complete the loop. Now, before we move on, we need to talk about clockwise and anti-clockwise motion of current. Here, if a current is going in anti-clockwise motion, then it is taken as positive. But if it is taken in clockwise position, it is taken as negative. Please remember these. Now, in loop ACDFA, well, let's write the law first. Sum of EMF equals sum of voltage. Well, we know volt is equals to current into resistance. So here we have one current EI. Take notice of where it is going. It is going in anti-clockwise direction, so it is taken as positive. Now let's take E3. It is going in anti-clockwise, so it is plus. Now here for the E1, the first EMF1, here the current I1 and R1, that is the potential difference of E1, plus is going anti-clockwise direction, I3 into R3. Here you may say that it may split to I2 and I1 here, but that's true. But then again, at this junction, I2 and I2 add up to give I3 here. So in these B, C, D, E, this path I3 runs. So now this is the first one, and again in loop A, B, E, F, A, E1 anticlockwise, but here this E2, so the I2 current is going in clockwise direction, so we have to minus the E2. This equals to I1 R1 minus I2 R2. Again in the last loop, B, C, D, E, B, E2 plus E3 equals to I2 R2 plus I3 R3. These are the Kirchoff's first and second law, but before that we also need to know what this principle is based on. It is based on the conservation of energy. It's, I think, obvious. To have the sum of EMF to be sum of voltage, it must require some energy to produce that EMF and to produce the voltage. So equally, they must have the same energy. Now, let's look at one numerical. Here, the question asks us to find I1, I2 and I3. But here in the figure, let's denote the resistances. Let's say this is R1, this is R2, and this be R3. Now quickly, let's look at the junctions. Here, let's take junction F. So, which law can we use? The first law. At junction F, using KCL, you can write it as KCL and KVL. Kirchoff's current law, Kirchoff's voltage law. Here, let's see the currents going into the junction. Here, I1 is going into the junction, so you take it at the left side, and I2 is also coming in, so we also take the left side, and I3 is going out. This is our first equation. Now let's look at the loops in this figure. We have three loops, mainly the outside ones and the two inner ones. But here, let's take the first small loop. In loop ABCFA, we can use Kirchoff's second law, KVL, the loop rule. Now, we know that the sum of EMF, what is the sum of voltage? Sum of current in resistance. Now here, a little bit mistake in the figure. E1 and E2 are given. Here, in this loop, there is only one EMF, which is 35. But let's write it down casually. E1 equals to I1 R1. But here, we have to use the clockwise anti-clockwise rule. This is going clockwise, so it is negative. This is also negative, and this is also negative clockwise, which is I3 into R3. Now since these three are all negative, we can just cancel that out. So we have E1 as 35 equals to I1, R1 is 3, plus I3 into 2. This is our second equation. Now let's take the second loop. In loop DEFCD, we'll take it from here because I2 and then I3, which will be easier for us. This is going in anti-clockwise direction, and here the only EMF we have is E2, so this is going to be positive E2 equals to I2 R2, and this is also anti-clockwise, so it is I3 R3, or 40 equals to I2 R2 is 4 plus I3 2. This is equation 3. Now in equation 2, we have 35 equals to I13 plus I32. Here we know that I3 equals to I1 plus I2. So using equation 1, we have 35 equals to I13 plus 2 bracket I1 plus I2. Now let's do some quick math here. 2I1 plus 3I3, 3I1 is 5I1 plus 2I2, equation 4. In equation 3, we have I3. We can convert that to I1 plus I2. So let's do that. In equation 3, 40 equals to 4I2 plus 2I3, but let's just replace that here, I1 plus I2, using equation 1. 40 equals to 4I2 plus 2I2, that is 6I2 plus 2I1. Now we can see in equation 4 and 5, we have on ax plus by equals to c and ax plus by equals to c, which is a linear equation. Thus we can solve it, and I will be using the elimination method. Here, let's multiply everything by 3. 35 into 3, 105 equals to 15 I1. This would be I1 plus 6 I2. Now let's just do minus minus minus. This and that cancels. 105 minus 40, 65 equals to 13 I1. So I1 is equals to 5 current. So now that we have I1, let's go back to equation 4. 35 equals to 5 I1 plus 2 I2. Now 5 into 5 is 25, minus here 10 equals to 2 I2, and I2 is also 5 ampere. And simply from equation 1, we have I3 equals to I1 plus I2, which is 10 ampere. So we have found it. I1 equals to 5 ampere, I2 equals to 5 ampere, and I3 equals to 10 ampere. That is all. I hope you guys understand, and please subscribe and like the video for more content like this and to get better at physics, math, or even chemistry. Thank you.